Hi all. So this video we are going to try to understand the proof of root 2 being an irrational number. So we all know that root 2 is an irrational number. Here we are going to try to prove it that it is actually an irrational number. So to prove it, there is a prerequisite that we need to know, that is that if a prime number, let's say p, if p divides a square, then it will divide a also. What does this mean? So if we take an example, right, if we take suppose 36, okay, and we take its two factors as 3 into 12, okay, so we know that 3 divides 36 because 3 into 12 plus remainder is 0. So that's why we say that 3 divides 36. Okay, if you see 36 is also 6 square, right, and we can see that 3 divides 6 also, because obviously 3 into 2 plus 0 is equal to 6, so we get the remainder as 0. When we multiply 3 by by some other number, we are getting exactly 6. There is no remainder. It's 0. So 3 is dividing 6. So this is true for all numbers. If you check, if you can take any perfect square and do its factorization, and the prime number in that factorization will be present in the square root of that number also. The main point here is only it is applicable only if p is prime. Suppose if we take a non-prime factor, right? Suppose 12 we take. 12 divides 36, but 12 will not divide 6 because 12 is greater than 6. It won't divide 6 properly. It won't divide 6, right? But if we take the prime number, 3 divides 36 also, and 3 divides 6 also. So if a prime number p divides a square, then it will divide a also. Okay. So this is one thing we need to know before going on to prove that root 2 is an irrational number. Let me clear the board. Okay, nice. Okay, so now let's try to prove root 2 is an irrational number. So we will assume first that let root 2 be rational. This would imply root 2 can be expressed as p by q, definition of a rational number. Now p by q, for example, if we take the number 30 by 40, we can always divide the numerator and denominator by a common factor 10, and then we will get 3 by 4. Similarly, maybe p and q also have some common factor, and so let's divide p and q by its common factor, and let's say that the final numbers that we come up with is a by b, such that a and b have no common factor, so that it can't be reduced any further. Here 3 and 4, they don't have any common factor, so it can't be reduced further. Okay, so this is our starting point, that root 2 is equal to a by b, where a and b have no common factor. Okay, now let's rearrange this equation root 2 is equal to a by b. So if we multiply both sides by b, we will get root 2 into b is equal to a. If we square both sides, what we will get is 2b square is equal to a. Okay, so if I just interchange the LHS RHS, we can say a is equal to 2b square. Why I am doing this is because now we can see that a is equal to 2 into something plus 0. Oh, sorry, a square. Yeah. So a square is equal to 2b square plus 0. That means a square is equal to 2 into something plus 0. What this means is 2 divides a square, right? Since remainder was 0, 2 into some number, and we didn't get any remainder. So we can say that 2 divides a square. And earlier we saw that if a prime number 2 is dividing square of a number, then that would mean it will divide the number itself, right? So we can write it as 2 divides a. If 2 is dividing A, we can write A as 2 into something plus 0, which is 2C. We can just write A as 2C. Okay. So now if we substitute A is equal to 2C, let's say in this equation, what we get is 2B square is equal to 2C whole square. That would imply 2B square is equal to 4C square. If we divide both sides by 2, we will get B square is equal to 2C square. Okay. Now again, if we see B square is equal to 2 into something plus 0, right? So what can we say? 2 divides B square. That would again imply 2 divides B, right? So now we see that 2 divides A, 2 also divides B, which means A and B have a common factor, which is 2. But here we had assumed that A and B have no common factor. So there is a contradiction. Why did this contradiction arise? See, from this point, right? From this point and below, all we did was rearranging the equations, squaring them and dividing them with the number. So below this point, nothing is wrong. It can't be. It is just mathematical. So only thing that could be wrong is above this, which is our assumption that root 2 is a rational number. So hence this is a proof that root 2 is not a rational number, it is an irrational number, because there is nothing other than that assumption that could have gone wrong to arise this contradiction, right? So hence we can say that root 2 is an irrational number. So hence proved. This same process can be applied for root 5, root 7, or any other number you can think of. Instead of 2 coming as common factor of A and B, 5 will come as common factor, or 7 will come as common factor of A and B, and we will be able to prove that that particular number is irrational. Okay. So thank you. I hope you understood the proof of root 2 or any other root 7, root 11, anything you can prove that it is an irrational number. Thank you. Thank you so much.